Hey, welcome to the Virtually Speaking podcast. My name is Pete Flecha, and joining me as usual is my good friend, Mr. John Nicholson. John, how you doing?
Good. I feel like, it's Christmas. I've got all the new presents. I'm looking at the boxes. I'm reading all the line items. Like, this looks cool, but I really want to dig deeper in to where we're going with this.
Absolutely. It's launch week for VCF 9, and as we all know, VCF is made up of a lot of great parts, right? 3 core components: compute, storage, and networking. There's a lot of other things, automation and management, but it all boils down to that foundation, the core infrastructure. And joining us to talk about that core infrastructure is a good friend of our show, is Vijay. Vijay, welcome back.
Thank you.
Vijay leads products for VCF, and you've been sharing us the secret sauce for a little while internally. I'm excited that we can finally talk about it publicly. And so before we dive into the products, I would love to get your perspective on what VCF 9 looks like for folks.
I mean, the big focus for VCF 9 is bringing together of compute, storage, networking, and automation and operations into one product and provide a single user experience, right? And so we're truly excited about that because customers, this is a long-standing ask for us. We released VCF, the product, a few years back, right? But we never fully realized the vision of that product until 9.0. So I think it's going to be a major release for our customers and hugely beneficial. But beyond the integration and bringing together the products, we've also invested quite a bit in the core infrastructure and innovation in the core infrastructure. So lots of capabilities coming out in 9.0. We've talked to you about this previously, but now we can share it more openly and more broadly. And so that's what I'm here to talk about. So, the core infrastructure, the key capabilities in the compute layer, the storage layer, and on the networking layer as well.
Yeah, well, let's do it. Let's start with compute.
Okay, so as you know, vSphere is a gold standard for virtualization, and over the last 20 years, we've made tremendous progress in terms of efficiency and cost optimization, et cetera. But now with 9.0, we're taking it to a whole new level. And so if you look at our customer environment, the biggest bottleneck in any environment is not so much the compute, it's not so much the CPU, it's memory, right? Memory is expensive, and the number of VMs that a customer can run on a single host, essentially the VM density, is in most cases, I wouldn't say all, but in most cases is bottlenecked by memory.
Oh, absolutely.
If you increase memory, you can run more.
You're buying sockets to get more DIMM slots. Is what it feels like half the time.
Right. Exactly, and this is what customers tell us too. And so, one of the things that we've been experimenting with actually for the last few years, and that's coming out now in the product, is can we identify blocks of memory that are not frequently used, and tear them off to a lower cost device, not DDR5, but lower cost device, NVMe. And a few years back, we didn't have NVMe as sort of the mainstream device, and so in the last few years that has changed, and you get a lot more capacity and higher performance as well. And also through our experiments, this is really important to understand, is that through a lot of experiments, what we observed was that in many cases, 50% of the pages in memory are on an average deployment is unused or infrequently accessed.
It's a read cache for a database or something. It's
exactly.
not. There's not transactional.
It's
batch
not.
processing.
It's not. And that's our observation. And so what we're delivering in 9.0 is a feature called memory tiering, advanced memory tiering, which the key IP here is really to identify those blocks or pages of memory in the CPU that are less frequently accessed, and we tear them off to NVMe devices. And this is a software-based solution, so there's no need for additional hardware. As long as the customer has inserted an NVMe device, we are good to go. And so this, we expect that the total cost for a customer, as because memory is the bottleneck in most cases, we expect the total cost to come down by 35%, 40%, sometimes even 50%, depending. Of course, all of this depends on the workload, so it depends on customer to customer, workload to workload basis. But on an average, we expect 35 to 40% increased saving. But the way to think about it is not so much cost savings, but how much more VMs can you pack into
more
that.
Density, absolutely.
More density into the.
Well, there's a long tail of savings there because you can run the same workload on fewer hosts.
Exactly.
You can or scale more hosts.
Exactly.
More workload, but also like there's secondary costs, licensing, your applications as databases aren't free per core. You can consolidate, pack that tighter.
That's exactly where the savings come from. Lesser number of hosts, more VMs per cluster, less to spend on software licensing, and so overall goodness. And so, and the first question that customers ask us when we talk about this feature is that, hey, what's the performance overhead, right? So, everything has a trade-off.
Everything
right?
has a little.
And so, but our experiments show that, again, on an average, the performance overhead is less than 10%.
I mean, this whole concept of promising more memory using some magic software, I mean, I think I remember RAM Doubler from several decades ago, and it was basically glorified swap. This sounds like this is a completely different, we're not having to take a huge performance penalty to implement this.
That's exactly right. And that's a true IP, right? That we're able to accurately identify those blocks that are infrequently accessed.
So is this like one of those things I'm a visual person, is this something that just happens in the background and I don't even know about it, or is there an administrator tweaking it?
It's totally transparent to the user, to the administrator, and software only, so it happens in the background, nothing that the customer or the administrator needs to do.
I don't know. This isn't like when you were trying to use PMEM, you had to have like the special file system, and you had to have the application had to be aware of it, like all this extra.
Yeah, none of those things here. Right?
Nice.
And so you can imagine that in the future, we can do a lot more with it. All right. And so this is sort of think of this as a beginning, first step in really redefining what ESX means for our customers. But then we have a lot more planned, with this first step.
I like it. That's a good start for core.
Yeah. So it's a great start for core. And just to complete the core.
Or compute, sorry, yes. Mm-hmm.
The big reason why customers prefer a private cloud is for data sovereignty, security, control over the resources. And speaking about security, again, vSphere is a secure platform, but then every release we keep taking it up a notch. And ransomware is a big, top of mind for customers, and so we're working on things to make it more secure. So one of the things that we are tech previewing or releasing in 9.0 in the next release is this thing called confidential compute. Right? And confidential compute essentially means that your runtime environment, including the data in memory, is encrypted. So your end-to-end data, your data at rest, your data in motion, your data in transit, and your runtime data are all encrypted. That provides a secure enclave for customers to run the most critical workloads, the most high security workloads.
The people who are legitimately concerned about someone physically getting access to their servers and having a bunch of liquid nitrogen to rapidly cool a DIMM so they can steal encryption keys.
Exactly. And believe me, there are such workloads, right?
Well, or if even if maybe it's not my server, it's in a shared cloud environment, and you're concerned about like Rowhammer and these previous cross-memory attacks. If that's encrypted, you've got additional shielding there.
And there are some customer segments like defense in various countries, where it's so critical to secure your data no matter where it lives. And so that is something that we are leveraging. We have partnered with Intel to leverage a technology called TDX, which sort of comes an encryption, in-memory encryption technology that comes with the CPU complex. So we're leveraging.
So we're not having to pay a high CPU cost to implement this.
Exactly. And so that's another critical enhancement that we are releasing in 9.0. So that's on the compute side. Every release, every few years, there are a new generation of CPU that comes into the market, new generation devices, storage devices, and so on and so forth. And of course, as with 9.0, we update our core platform to leverage those new CPUs. And CPUs are becoming more dense, a high number of core counts per CPU per socket. And so we continually make enhancements to our core, core virtualization platform to better leverage these new technologies in the market. And so that's going to happen in 9.0 as well. So that's sort of on the compute side.
It is interesting, like talking to the scheduler people and how going from 8 cores to 100 cores is not just changing some hard-coded values. Like you have to think about a lot of stuff inside those CPUs.
It is actually some deep computer science engineering, because you really have to understand how to understand inter-die latency and
You need to understand the physical properties of where stuff are inside these CPUs.
And I don't claim to be the sort of the smartest in this room for that, but man, there are some really smart engineers that look at it so closely. But then you need that level of like understanding of computer engineering to be able to support these new, CPUs.
And test those configs and actually validate those configs.
And that's constantly changing as well, so that's crazy.
Exactly,
So lots of enhancements in the compute side. What about storage?
Yeah, so this is my favorite topic because I was a storage guy, for a number of years, as you guys know. So storage, actually, we're sort of making vSAN ESA has been in the market for a couple of years, but one big gap that vSAN ESA had was that compared to the old version of vSAN was dedupe, right? And so we've actually addressed that gap with 9.2. I'm really excited about this because I do not know of too many storage vendors in the market that can do dedupe at the global level, across an entire cluster and at the object level, right? So for us, our dedupe is at the per VM or a per object level, and so we are delivering in 9.0 vSAN ESA dedupe. We're calling it global dedupe because it's global to a cluster. Across an
the hashes can match across every single drive in the whole cluster.
And so if a single drive fails, you only have to rebuild the single drive, right? And so that's going to give additional cost savings for our customers. And the theme here on the core infrastructure is better TCO for our customers. That's what we strive to do. Everything that we're doing is better performance, better efficiency, but it all comes down to a better total cost of ownership for our customers. And
that's it.
That's a big one.
Yeah, performance is certainly a part of it, but also the complexity and having all of that just reduced by
That's the whole theme here. So I'm really excited about that. I think we're going to have customers adopt ESA a lot more. I mean, we have seen tremendous adoption for ESA, but we'll see more with this feature. The other big investment that we're making in vSAN is beyond the core, sort of the core vSAN platform is in data protection, right? And again, going back to the theme of security, security is not just about someone attacking your environment, but also security is also about, hey, what if an administrator accidentally deletes a file, or what if you have a disaster event or a power outage? How do you recover from that? So we took the first steps towards this in the previous release with vSAN ESA snapshot management, right? For the first time in VMware's history, we have snapshots that can go deep and wide without any performance impact, right? And
immutability,
your classic deep snapshots, and this is not at the volume level, but at a per VM, or I should even say per VMDK level, really, right? At the virtual disk level. And so we delivered in the last release, we delivered snapshot management for vSAN clusters that can protect customers against accidental deletion or accidental corruption of VMDKs. Now, the natural next step from there is, hey, how do you replicate those snapshots, right, to a remote site for disaster protection?
Exactly.
Right? And so that's what we're delivering in 9.0. So think of it as vSAN native replication. Built into and when I say native, what I mean is that it's built into the vSAN workflows. vSAN administrator, person who knows how to administer vSAN, can, with a click of a button,
per VM replication, and then force snapshot retention on the remote side.
On the remote side, and independent of the source side, right? So you can say, hey, I want some retention of the source, which is like X, retention can be Y, and so a lot of flexibility. And so vSAN replication, vSAN data protection.
That is something that, like, the Pete from 10 years ago hears that, and it's like, get out of here, you're crazy. Because 10 years ago, when we first joined VMware, like, it was just, snapshots were not what they are today.
Snapshots were terrifying. We were like, please don't leave those open.
I absolutely remember both of you and a host of others saying, hey, when are we going to fix the snapshots, right?
Yeah.
And so,
we did a session at Explorer, it was VMworld back then, called Snapshot Suck.
Yeah.
And we got a little call from the product team for back then that said, don't do that. But we were basically saying, like, there's a lot of work that needs to happen here, and we are here, man. We've got the performance, but with the performance, you need that replication. So I really feel like we're arriving with VCF 9 when it comes to
and truly making vSAN a sort of an integral part of the VCF stack. right? And dedupe was a big thing that we big gap that we needed to address, but replication as well. And so that's getting addressed in 9.2. So that's
nice
on the storage side. And I just want to say before we move on to networking, there's a lot more here, right? That's coming. And so while I cannot talk about all the stuff that we're working on for the next release, but this is just the beginning. We can do a lot with this, with the foundation being snapshots and replication. You can let your imagination go wild, right, with respect to the stuff, the kind of stuff that we can deliver for our customers.
Yeah.
And so that's coming in the huge investment in this area for us. That's storage. Yeah. So compute, storage. Shall I go to networking?
Let's do it. Let's go networking.
Okay. So you guys are eager to hear about networking. I'll tell you about it. So networking, actually is a massive shift in our networking strategy compared to previously in the previous releases. One thing I just want to start off by saying is that when NSX is our networking the brand name for our product, right?
Right.
And NSX, when NSX was a separate BU, it was our goal was to go head to head with the networking vendors, Cisco, Arista, etc. Now with VCF as being sort of being positioned as a private cloud platform, as an alternative to public cloud, really, right? We're no longer thinking about NSX and networking as competing with vendors. In fact, just like storage, we want to partner with.
Somebody's got to push the packet.
Yeah,
so.
Exactly. Yeah. So we want to partner with our storage partners, and so we have a lot of ideas on a lot of initiatives on making our networking stack work better with our storage vendors. But the first step towards that is bringing a notion of virtual private cloud, VPC, into the stack, into VCF, right? And so, what is VPC? What are VPCs? VPCs think of VPCs as essentially an isolation domain, all right? And so, VMs within a VPC can talk to each other, but VMs outside of across VPCs cannot talk to each other, right? And so
isolated broadcast domains
at the most simplest
by an overlay.
Yeah, you're a networking expert, so he knows all about that. So at the most simplistic level, that's what it is, right? It's an isolation domain for VMs. And VPC, we've had VPC in NSX previously, but it was never integrated into vCenter. And so we're bringing VPC into the construct and concept of VPC into vCenter, so anyone can leverage VPC.
Summon it by API
exactly.
Or automation.
Yeah, so your VI administrator can do this all inside of vCenter.
Create VPC if I want to click up.
Exactly, and you can start to provision your VMs and workloads on the VPC, and have total isolation between
without having to go open tickets with my networking team.
That's the whole
wait
point.
3 days.
That's the whole point. You don't need, for the isolation that for that level of isolation, you don't need to go and fight with your networking team. In fact, again, as we think about the future of networking in VCF, we're trying to figure out how do we better integrate the physical stack with our virtual stack, right? And so that's a big shift in our sort of strategy, if you will. And VPC is a first step towards that, and we're extremely excited about that. And one other thing to add about VPC is that VPC is a fundamental primitive, fundamental construct, I should say, in vCenter that can be leveraged in many places, including our automation, right, and Kubernetes, based workloads. When you provision it, just like you would provision workloads in the public cloud, and if you go to AWS, you just create a VPC and you start provisioning your workloads. In exactly the same way, we've integrated VPC into our automation layer. So when a customer end user goes and provisions workloads, you can say, hey, create me this VPC, and I'll start to provision these VMs into that VPC. And so it's integrated across the entire stack in VCF.
That's the way it should be.
And one last thing on networking, I'll just say is, again, as you can imagine, this is sort of the first step, and you can imagine all the cool policies that we can develop on top of this construct, and that's in the future. So I won't talk about that.
I won't tell anybody. Go ahead.
And then the last thing I want to say about networking is that that's on the isolation piece, but in the core data path, we are coming out with a new data path, new switch in NSX. It works with both NSX and VDS, but essentially new switch, a new data path that increases the throughput by 3x.
Oh wow!
Wow.
And so humongous savings.
How do we do that?
You have to ask engineers what they did.
No, it makes sense.
It's incredible.
Yeah, there always were some performance limits, so to speak, on some of that stuff, and trying to figure out okay, how do I tune this, or how do I push? There are people who have these giant VMs that are just pushing huge amounts of networking traffic, and they're always having to felt like unnatural things to try to get there.
Exactly right. And so lots of cool capabilities in the core infrastructure. And so the main focus is bringing all of this together, but we haven't lost sight of the fact that the innovation happens at the core infrastructure, and we'll keep doing that.
I appreciate you come on here and dive into the individual details of the products, because I feel like there's this slight preconception of, you've got a VP, he's just going to say the word cloud a bunch of times and wave his hand, but no, we got into the weeds here of what's going to be cool and better.
Yeah, I try to keep myself up to date and smart sometimes. So
Vijay, this is exactly what we were looking for. We a little deeper look into the core. Thanks for joining us this week.
Of course, yeah. Thank you so much. Always fun to be here.